Now first let us see what is fundamental theorem of arithmetic. So every composite number we can express into product of primes in any Q way. This is a fundamental theorem of arithmetic. What is it? Every composite number, any composite number, we can express into product of primes in any Q way. For example, you take 72. This is a composite number. So what is composite number? The number having more than two factors. So 72 has more than two factors. So it is a composite number. Now this number we can express into product of prime numbers. See how. So you take 72. You can write 72 2 into 36. Again 18 you can write 2 into 18. 18 you can write 2 into 9. 9 you can write 3 into 3. So 72 you can write it is equal to 2 into 2 into 2 into 3 into 3. Is it? So 2, 3 both are prime numbers. So like this 72 you can write into 2 into 2 into 2, 3 into 3. So like this every composite number we can express into product of prime numbers. This is called fundamental theorem of arithmetic. Now HCF and LCM. HCF means highest common factor, LCM least common multiple. How we can find HCF and LCM of two numbers? For example, you take 72 and 108. So there are three methods to find. If you want to find HCF and LCM, one of them is prime factoration method, division method, writing factors or multiples. So first let us see how we can find HCF and LCM of 72 and 108 by writing prime factoration method. Look here. First you take 72, you write 72 into product of prime factors. So you can write 2 into 2 into 2, 3 into 3. So 2 2s 4, 4 2s 8, 8 3s 24, 24 3s 72. So 72 you can write into product of prime factors like this. Now you take 108. So 108 also you write into product of prime factors. So 2 into 2, 3 into 3 into 3. 3 3s 9, 9 3s 27, 2s 54, 2s 108. So first you write both numbers are in prime factoration, product of prime factors. Now how you can find now HCF now first. So you take a common factors. Here 2, one common factor. So you write 2. So one more pair also have 2, 2. Again you write one more 2. Next 3 is there. 3, 3. Common 3. One more 3 also is there. Common. Now you multiply 2 2s 4. 4 3s 12. 12 3s 36. So 36 is the HCF of 72 and 108. Now you find LCM. So first you write all these numbers. What numbers you write here? That 2 into 2 into 3 into 3. And the remaining numbers here into 2. And here remaining one more 3 is there. Now you multiply 2 2s 4. 4 3s 12. 12 3s 36. 36 2 72. 72 3's 216. So 216 is the LCM of 72 108. So in this way we can write, we can find HCF and LCM of two numbers by writing product of prime factorizations. So here you can remember one thing. What is the relation between two numbers and HCF and LCM? Suppose if you take the two numbers, let two numbers A, B you take, and HCF you take G you take. G means the greatest common divisor. HCF is also called greatest common divisor G. And LCM you take L. Now the relation among these two numbers HCF and LCM is the product of two numbers, that is A into B, is equal to product of HCF and LCM. So AB equal to GL. So product of any two numbers is equal to product of their HCF and LCM. So with this relation, when you are given product of two numbers, and now let us see what is the relation among two numbers and their LCM and HCF. So A and B are here two numbers, and L is the LCM and G is the HCF. So product of any two numbers is equal to the product of their LCM and HCF. So with this relation, say if you are given HCF, that is G, you can find L. L equal to, you can write the product of two numbers by G. Same way we can find when you are given LCM is given, we can find HCF. G equal to, that is HCF equal to product of two numbers by LCM. And when you are given two LCM and HCF of two numbers, we can find one more number. When you are given one number and their LCF and their HCF are given, we can find a second number B equal to LCM and HCF by first number. So with this relation, we can find among these four values, when you are known three values, we can find third one also. Thank you. Now what are rational numbers? The numbers which can be written in the form of P by Q, and where Q is not equal to 0. They are called rational numbers. So we can say all integers we can call rational numbers. Suppose 5 is also a rational number. We can write into 5 by 1. 0 is also a rational number. We can write 0 by 1. So any rational number which can be expressed into P by Q form, where Q is not equal to 0. So here standard form of rational number is P by Q, and where P and Q are co-primes and Q not equal to 0. So P by Q is a rational number. It is a standard form of rational number. when both P and Q are co-primes and Q is not equal to 0. So they are rational numbers. And rational numbers means again one more we can say all terminating decimals and non-terminating and recurring decimals. Are also called rational numbers. So rational numbers means you must remember the number which can be expressed into P by Q form where Q is not equal to 0. Now every integer we can write into rational number. All integers, all natural numbers, all whole numbers we can write into P by Q form. They are all called rational numbers. So what is the standard form of rational number? P by Q is the standard form of rational number when P and Q are co-primes and Q is not equal to 0. Not only that, all terminating decimals and non-terminating and recurring decimals also called rational numbers because we can express them into P by Q form. They are also. So they are all called rational numbers. Now let us see what are irrational numbers. So the numbers which cannot be written in the form of P by Q we can call irrational numbers where Q is not equal to 0. So we cannot which cannot be written in the form of P by Q. So under square root, suppose root 2, root 3, root 5, these are all irrational numbers. Not only that, non-terminating and non-recurring decimals are also called irrational numbers. So we can see this example. So what are irrational numbers? The number which cannot be written in the form of P by Q. So where Q is not equal to 0. So under root, if it is not a perfect square, then they are also called irrational number. So we conclude that non-terminating and non-recurring decimals called irrational numbers. Now root 2 is irrational. How we can prove root 2 is irrational? So let us assume root 2 is not irrational. So here with the help of contradiction we are going to prove here. So root 2 is irrational. Actually we want to prove. So now we assume that root 2 is not irrational. If it is not irrational, what it will be? It is rational. So you take then root 2 is a rational number. It is rational. When it is rational, as we know, any rational number we can write into P by Q form. So here root 2 equal to we can write P by Q where P comma Q are co-primes. Co-prime and where Q is not equal to 0 here. So co-prime means it has only one only as factor. So root 2 equal to P by Q, since we are taking here rational number, So where P and Q are coprimes. Now here squaring on both sides. Squaring on both sides. Then this side root 2 square we get 2 we get. And here P by Q square whole square, then we get P square by Q square. So from this we can write, if you do cross multiplication, we can get P square equal to 2Q square. So clearly we know that here 2Q square is a multiple of 2. So 2Q square it is even. So when 2Q square is even, then we can say P square is also even. So we can write P square is even. When P square is even, we can say P is also even. P is even. So we know any even number is in the form of 2n. We know it. Where here n belongs to z. Any even number we can express into 2n form. So here we have 2q square equal to p square we have. 2q square equal to p square. Now you substitute here p square. P means 2n, you substitute now. 2q square equal to 2n whole square, which is equal to 4n square. Then we get q square equal to 4n square by 2, which is equal to 2n square. Again 2n square, it is a multiple of 2, so it is even. So which is equal to q square. Therefore q square is also even. When q square is even, we can say q also even. So q is also even. So already we know p is even and q is even. So what we have here, we got here both p and q are even. Both p and q are even. But then 2 is a common factor here. 2 is a common factor of both P and Q. But P and Q are coprimes here. 2 is a common factor of both P and Q. Since P and Q are coprimes, they have only one only as common factor. So here P and Q are coprimes. They have only one common factor. So a contradiction is formed here. So P and Q are coprimes. Coprimes means they have only one only. They have one only as common factor. So it has one and one only common factor since both are coprimes. So here a contradiction is arised. So a contradiction is arised. So here a contradiction has come. Why? Since we are taking wrong assumption. What we assumed there, root 2 is not irrational. So we conclude that root 2, it is true to say that It is true to say that root 2 is irrational. Understand, here actually when P and Q are even numbers, we get, by taking wrong assumption, we get P and Q are even. When both are even, we can get 2 is, we can have 2 is the common factor. But here P and Q are already we defined their co-primes. So co-primes mean they have only has common factor. There is no other factor other than 1. So here a contradiction is formed here. So therefore, since by taking wrong assumption, a contradiction has come here, so it is true to say that root 2 is irrational. Is it clear, all of you? Thank you. Now 6 plus root 2 is irrational. How we can say it is irrational? So here let us assume that 6 plus root 2. 6 plus root 2 is not irrational. So it is not irrational, then we can say 6 plus root 2 is rational. So any rational number we can express into P by Q form. So here 6 plus root 2 you can write P by Q form, where P comma P or Q are co-primes. Now this we can write root 2 equal to P by Q minus 6 we can have. Or you can write root 2 equal to, take the LCM 6 here, we can have P minus 6Q. So one side here root 2 is irrational, P minus 6Q by 6 is rational. So it is a contradiction to say both are equal. A rational number is never equal to irrational. So a contradiction formed here. So here root 2 is irrational. Root 2 is irrational. And P minus 6Q by 6 is rational. So one side we get irrational, other side is rational we get. So they never equal. So it is a contradiction. It is contradiction to say that root 2 equal to P minus 6Q by 6. Why? This is irrational and this is rational. They are never equal. So it is contradiction to say equal. Therefore, we can say 6 plus root 2 is irrational. This is only true to say. Now let us see. 3 plus 2 root 5 is irrational. So here also, with the help of contradiction, we can prove. Let us assume that here let us assume that here 3 plus 2 root 5 is not irrational. So when it is not irrational, then it will be 3 plus 2 root 5 is rational. As we know, any rational number we can express into p by q form. So you can write here 3 plus 2 root 5 equal to p by q. So where p, q both are co-primes. Now see how we can get contradiction. This you can write 2 root 5 equal to p by q minus 3. Or you can write 2 root 5 equal to q here LCM p minus 3q. Or you can write root 5 equal to p minus 3q by 2q. This 2 here it comes. So here a contradiction formed here. What it is? One side here root 5 we know it is irrational. P minus 3q by 2q is rational. A rational number and irrational number, they are never equal. So here it is contradiction to say that root 5 equal to p minus 3q by 2q. Why here? Because root 5 is here irrational. And right side we have p minus 3q by 2q is rational. We know they are never equal. Rational number and irrational number are never equal. So it is contradiction. It is contradiction. It is contradiction to say that a rational number equal to a rational is equal to irrational. So therefore therefore it is a 3 plus 2 root 5 is irrational.